Did you sign the attendance? It did not come. Where did we stop in the last class? Numericals. Yeah. We completed numericals. How many I did? 3, and rest I had asked you to try, right? Any difficulty in rest of the numericals? Any difficulty? You all try?
We did first, second, third, and 7th.
7th also we did. So we got the answer for 7th?
Yes, sir.
Okay. Shall I start the next unit?
Yes.
I start the next unit?
Yes.
Okay. So measurement.
We have not started.
Yeah, measurement of length. So now the interesting part begins. Okay, so far it was very abstract and too many new things. So let's begin. Unit B. So measurement of length. So how do we measure length? We need an instrument, right? So what are the measuring instruments for measuring length? So we are familiar with meter scale, right? So then,
So there is the one student KHR.
What is KHR24? What? Even I have not. Is she expected to come?
We don't know, sir.
Leave it. It's okay. I mean, we don't know whether she's on leave or something. Meter scale. Then you have what are the other instruments? Yes. Take the attendance sheet. And you have vernier calipers. You have screw. These are some of the instruments which are used to measure lengths, right? Now, every instrument has a smallest measuring capability, right? So, what is the smallest length a meter scale can measure? 1 centimeter. 0.1 centimeter, right? 1 millimeter, right? So, it can measure .1 centimeter onwards. Okay, this is the smallest length it can measure. But what if I want to measure the thickness of this paper? How thick is this paper? Is it 1 millimeter? Almost. Is it 1 millimeter? Even a chart paper, it's less than a millimeter. So how do we, can we measure it with the meter scale? No, we cannot, right? So we will use vernier calipers. Then what about the diameter of this hair? It's thinner than even this correct? So we need small, like measuring devices which can, measure smaller lengths such as vernier calipers and screw gauge. So it can measure how many? 0.01 centimeter onwards, like 1/10, the smallest length, okay, which a scale can measure. This device can measure 1/10 of that smallest. Okay, so that precise it is onwards. The screw gauge can measure how much? 100. 0.001. So 100. So you make 100 parts in 1 millimeter. One part of that is a screw gauge. Okay. So isn't it interesting? Now these are new instruments that you're saying, right? So onwards. So the smallest measurement. So there is something called as least count. Least count or LC.
How to calculate the point?
Yes. We can see that. The smallest measurement and instrument can measure is called its least count. Least count. Okay. So we need to know how to calculate the least count of a instrument, right? For meter scale, it is straightforward. 1/10 of the centimeter is 1 millimeter, right? So let's see how to calculate least count of. So vernier caliper short form is ECD. Screw gauge is SG. Okay. So let's find out the least count of vernier calipers. So least count of vernier calipers is equal to difference of the difference in the value of one main scale division and one vernier scale division. Okay. This is the formula for least count of vernier calipers. What is MSD? Where? In scale division.
Main scale division, vernier scale division.
Yes. Yes. Vernier scale. Okay. So if you see the diagram of vernier calipers in your textbook, this is how it looks. Okay. So first you write what is there on the board, then I'll explain how to find this. Google.
So this is really good that actually we can use a guest code because
Where is guest?
so
Sign.
you can sign in or you can use a guest.
Yes.
What? When I,
Okay.
yeah. Where is it? Where is guest?
So
I need a Google tool. You say alt tab, then you'll get that. Alt tab. Alt tab. Take Swati करो. It's okay. ठीक है. I. So. So now see, these are, this is similar to a diagram in your book. So what you see here is the main scale, the normal main scale that you're familiar with. Okay. But apart from this zero, there are these jaws fixed. So these are like outer jaws. Okay.
and then I know.
So this jaw is fixed on the part of the main scale, right? Then there is a vernier scale. Can you see this? This is a vernier scale. And this is a sliding, it slides over the main scale.
To measure the depth of a substrate.
So depth will be measured by this strip. The strip is fixed to this vernier scale. There is a screw. You can roll it. Okay, you can slide it with the help of this roller. Okay. And what all can you measure? You can measure the diameter of this. So you hold it between these jaws by sliding left and right. Okay. So diameter could be like one is external diameter. So for external diameter, you'll hold it with the lower jaws, or it is called outer jaws. Okay, how to hold it? So you can slide it, you can hold it like this. To measure the internal diameter,
You have to use the
upper ones. Okay, the internal and external. This is all. Okay. So, and then if I want to measure the depth of the bottle, say small bottle, then I will just slide it, put the dipstick inside. And whatever is the reading, we have to calculate the reading from here. Is it clear? Okay. Now this is a like very advanced vernier calipers. The one you will be using is, you can see your textbook. This is the vernier scale. There are marking on the vernier scale. Okay, it's only 10 divisions.
10 divisions of 1.
10 divisions of vernier scale. It could be 20, could be more also, right?
Basically it is 10.
It is 10 for you. So right now, for understanding, we'll begin with 10. Then we'll increase. We'll see how it is. So one division on the main scale is 1 millimeter. That's the value. What is one main scale division? 1 millimeter. This you are familiar with. Okay, or 0.1 centimeter. 1 millimeter is 1 centimeter divided by 10. Okay. Now these divisions on vernier scale are marked such that it fits into like the length of the vernier scale division, total division is 1 less on the main scale. Like if there are 10 vernier scale division, it will fit into 9 main scale divisions. Got it? That's how the divisions on vernier scale is done. Right? So note. the vernier scale divisions are marked and let's say there are n vernier scale divisions are marked in n minus 1 main scale divisions. This is the principle of vernier. Okay, I'll write it as principle of vernier calculus. N vernier scale divisions are marked in n minus 1 main scale division. Right? So, if one main scale division is equal to x millimeter, right? Whatever, then n vernier scale division will be equal to n minus 1 into x. Isn't it? See, so like if that is, let's say you have 10 vernier scale division. How many divisions it will fit into? 9. 9 main scale divisions. This is what I explained, right? Yes. How much is one main scale division? 0.5. So it will be how much? So it is 9 into, this is 9 millimeter. Because 9 main scale division corresponds to 9 millimeter. Therefore, one vernier scale division will correspond to how much? 9 by 10. 0.9 millimeter. Correct? For your example. Because in your textbook, 10 vernier scale divisions are marked in 9 main scale division. Okay? So this is how the principle of vernier calipers is. If the vernier scale has 20 divisions, then it will fit into 19 main scale division. And one main scale division is always equal to 1 millimeter. Always. So that is the principle of vernier calipers. So now we know what is the value of one vernier scale division and value of one main scale division. So what should be the least form? That's 1 MS3 equal to 1. Okay, so 9 MS3 is 9 millimeter. Got it? One main scale division is 1 millimeter. So 9 will be 9 millimeter and therefore divided by 10. So this is the value of one vernier scale division. Is it clear? Okay. So here also we can get therefore one vernier scale division. This is the general formula. Is equal to n minus 1 divided by n times x. So remember this. These are two. This is a special case of this formula. This is a specific example, but this is a general formula. So therefore, what is least count now? How much is this? One main scale division. When we take main scale division as x, minus how much is vernier scale division? N minus 1 divided by n x. Correct? Sorry. So what is this? This is x minus n by n x minus plus x by n. This is x minus x. So what you will get is x by n. This is the general formula of least count of vernier calipers. What is x? X is one main value of one main scale division divided by total number of divisions on vernier scale. Okay? That is it. You go one main scale division divided by total number of divisions on vernier scale. This is the formula of least count of vernier calipers. Okay, so the derivation of the formula is not expected, but you must know how to find the least count. And I have explained how to find it. This is the example. This is the general formula. Clear? Anybody not clear, please ask. Okay. So, what is the least count for this case now? So, one main scale division is 1 millimeter minus 0.9. So, it will be 0.1 millimeter. So, we get this. 0.1 millimeter is 0.01 centimeter. Okay. So, can I erase this part?
Yes.
By this formula, therefore LC of AC. What is value of one scale? One main scale division, 1 millimeter. Divided by 10. This is 0.1 millimeter or 0.01 centimeter. Clear? So with the help of this formula, whatever is the given value in the numerical, you will be able to find the least count of vernier calipers. Right? So if I give you a task, let us say n is equal to 20, then what is the least count? Find out. There are 20 divisions on vernier scale. This is the formula for n equal to 10. So for n equal to 20, what it should be? Yes, because main scale will always remain 1. It will be half of this. So what it will be then? 0.2 n. 0.02. Yes, that way. Okay. This is how it will do. All right. Similarly, we will calculate least count of screw gauge. Can I erase this?
Yes.
Now let me display. This is better, right? To understand the instrument and all. So let's figure out. Let's find out how the screw gauge looks like. In the but I don't have one here. So I thought I'll put it. So this is how the screw gauge looks like.
There are two types of vernier scale, which is one is this type and one which is in a rectangular box. Aksharas
Rectangular box.
and just like image is given in the text. Touches. This
This is okay. So like this is just the design. So this is a better design because it shows all the main scale divisions. Here it is not showing. That's only. Okay. This one is a better design. Okay.
and a map also told that the zero touches the
That's the zero. Right now we are becoming familiar with the instrument. Then we'll see how to use it to measure various things. So let us now first calculate the least count of screw gauge also. Then we'll see how to measure. Okay. So that is then.
so we are on Google. So that's your you can click on one
Calipers.
Yeah.
We have to close it. I think we should close this. Everything is closed.
So we have to change the key.
Wait, wait. There is the
Thing inside the main room. Right.
it's okay. So what is that? Screw gauge. I'm not hacking into yes. Yes. Now I'm familiar with the okay. It's available for 300 rupees. वेरिएंट में कैसे चला गया? And no, this is hidden. Can't go back. Take it. Go to images. It's a better one. Open this. Go back again. Go back again. Go back to images. Wait. There was one. This one. Labeled. या फिर ये वाला लेना ये ज़्यादा better. Very good. ठीक है ये छोड़ो. Now see, so this part, okay, this U frame, right? U frame and this sleeve, okay, these are 1 unit, okay, and this thimble or cylinder, this cylinder with this marking, this is 1 part. So what is happening is this whole thing along with the screw, there is 1 screw coming out of this like this. This will enter here. Now when you're rotating, so this is the main scale. Can you see this? The U part and this is the main scale. And when you rotate it, this screw will come and get attached with this. So this is the fixed part. It's called what? Stud, right? Stud. It's called stud, right? Here it is written angry. Go with the terms given in your book. So the fixed part is called stud. And this is the screw. This screw and this circular scale, they are 1 unit. So when you rotate this circular scale, there are 100 divisions. Can you see this? So 0 to 100 division. These are called circular scale division. So like what was vernier scale? Vernier scale 10 division. Out here you have 100 divisions. Okay? With multiples, right? And it could have 200, 500, right? If you want to increase the precision, you can have more and more divisions. Then, what happens is, what is the principle of screw? If you rotate the screw like this, it travels linearly, isn't it? When you tighten the screw, it will go left. When you tighten, it will go left. When you release, it will go right. Okay? Yes. Now, so what is there in the screw is, you have seen, screw has these threads, right? you must have seen the nuts and bolts, right? These threads are there, isn't it? Let us say this is a bolt you must have seen, right, in your cycle. So when you do it like this, or even, so you understand what is thread, right? Can you see what is thread? These are the threads of the bottle. So there is a dip and peak, dip and peak. So this two, when I rotate it by one turn, it moves by one thread. You understand? So if I rotate by one full turn, so when I rotate it by one full turn, let us say like this. Okay, this direction I rotate. So meaning when I rotate by one full turn, how many circular divisions I rotated? So from 0, I started from 0 and came back to 0, meaning 100 divisions. Then this screw moves by one thread. This is the principle here. When the thimble is rotated by one full circle, then the thread advances by one division. Okay, and the distance between thread is 1 millimeter. Got it? Meaning, when I rotate the thimble by one full turn, it will travel 1 millimeter. Okay, so if I just rotate it by one division, so it will travel how much? 1 divided by 100. That is the least count of screw gauge. Got it? So the distance between the thread is called pitch. Okay, so how do we calculate the least count of screw gauge? Is equal to pitch divided by number of circular scale division. Number of circular scale division. So what did I tell you? Pitch is generally 1 millimeter. Okay. So 1 millimeter divided by 100. How much it is? 0.01 millimeter. Correct? 1 by 100 is 0.01 millimeter. So how much centimeter it is? 0.01. So this is the smallest length which a screw gauge can measure. So the object whose length we need to measure has to be held here between the stud and the screw. Yeah. This here. Close it.
It is the other first time.
This one.
Yeah. Click return to it. Second. So you can just close Google, it will get closer.
Yes, sir. Okay. So are you all with me? How to calculate the least count of vernier calipers and least count of vernier screw gauge? Okay. So basically, when we want to measure the diameter of a wire, for example, then we will keep the wire between these two and try to use the ratchet. Why ratchet? Because when we are tightening the object, when it is held between the two, if we move through the spindle, it might disfigure the object itself because it is very sensitive, right? So we should not rotate it so much that it just squeezes the object. Let's say like your pen refill. Okay, so when its shape also will get changed. That's why this ratchet is there. This has got some spring. So when you gently rotate it, at one point it will stop. And then when you again rotate it, you will know that now it's not free. So you stop there. But here, you might end up forcing it and the shape will change. Got it? So now there is a main scale and there is a circular scale. Okay? So now I will explain you how to take measurements. Having known the least count, now I'll tell you how to take measurements. Okay? So first by vernier scale, then by screw gauge. Our class is still 7:35, right?
Yes. 7:30.
7:30. So we are 20 minutes. So taking measurements. Everybody understood what is a pitch?
Yes, sir.
Pitch is the distance between consecutive threads, and it is equal to the distance moved by the screw when
When rotated.
when the thimble is rotated by one
by
turn.
turn.
One turn. Yes, exactly. One turn. That is 100 degrees. Yes. So taking measurements using vernier calipers. Okay. So measured value is equal to observed value minus 0 error. Zero error. Okay. And what is observed? Observed value. The observed value is main scale reading plus vernier scale reading. Okay. This is the observed value minus 0 error. Okay. Now how to take the main scale reading? It's very simple. Wherever this okay. Now see this example in your textbook. Figure 1.6. So the upper scale is main scale and the lower scale is vernier scale. Okay. So what is the main scale reading? It is 5.3. See wherever is the zero of vernier scale, all the reading before that zero is main scale reading. Okay. So MSR is main scale reading. So how much is this? For this example, it is 5.3. So taking L of example, reference figure 1.6 in Selena. Okay. So main scale reading is 5.3. Now what is vernier scale reading? How to measure the vernier scale reading? Now you find out which division on the vernier scale is matching the division on main scale. So you'll find that the 6th division on vernier scale is matching main scale division, the 6th one after 5.
Yes. So it is matching a little bit, it is not matching.
It is closest, right?
Yes.
Everybody understood?
Yes, sir.
Figure 1.6.
Page number 50.
Is it figure 1.6?
Yes, sir.
Can you see which division is matching?
Yes, sir. 6.
The sixth division of vernier scale is matching. So,
0.6.
so vernier scale reading is calculated by taking what is the division on the vernier scale which is coinciding with the main scale division multiplied by least count of least count. Okay, this is how the vernier scale is. Let me write down coinciding division. Into least count. This is how the vernier scale is calculated. Minus, for this example, there is no zero error. I'll explain what is zero error. So you just subtract 0.
0 error.
Zero error is not there. Means it is an accurate scale.
When the 0.
I'll come to it. When the zero, there are positive and negative zero error. So hang on. So let's go slow. So the true or the measured value. Okay. So for this example, it is 5.3. You will now know sixth division is coinciding. And what is the least count? 0.01 centimeter. Because this is main scale measurement is in centimeter. This is also in centimeter. So you have to choose the least count in the same unit as main scale division. Okay, main scale measure. So this will be 5.3 plus 0.06 is equal to 5.36 centimeter. Clear?
Yes, sir.
Now let's understand what is zero error. So this is the measured value. Okay, now it's now let's understand what is positive zero error. So when the jaws of the vernier calipers, when they are closed without any object, okay, then what will happen?
Then if the right side of the
So see, now see figure 1.4. Refer figure 1.4. Now, zero of the vernier when you close the jaws, right, by sliding without any object. So any object whose length has to be measured will be put inside the jaws the way I explained. But before taking measurement, you have to first check whether the instrument has a zero error. So when you close the jaws, zero of the vernier is lying on the right of the main scale. What does it mean? It means whenever you take any measurement, it will always tell you larger than the actual value. A little larger than the actual value. That's why you have to subtract the zero error from the measured value. Got it? So this is called zero correction. It is called zero correction. Now see the next figure. Negative zero error. So now you refer diagram 1.5. So if the zero of the vernier scale is always to the left of the main scale zero, that means whenever you take measurement, the observed value is going to be always less than the actual value. Because it is always showing you less value. So in that case, how will you correct? You have to add. So, but when you are writing what is the zero error, so you write it with negative sign. So negative will get added.
yes.
Okay, here the positive zero error will be positive, so it will be subtracted because it was showing
Negative.
more than observed value, more than the measured value was more than actual value. observed value is more than actual value, actual length, right? In the negative case, it is always showing less than actual length. So it has to be added. So minus, and when it is negative, then it will get added. Okay. Now let's write down how to find the zero error. So it's very simple. In this case, it is directly coinciding division. Into least count. And it has to be written with a plus sign. So for this example, you can see the coinciding division is 6, bigger 1.4. So it will be plus 6 into 0.01.
So minus.
Plus. It is positive zero error. So you have to write it. So this is equal to, we are calculating. Zero error is equal to the coinciding division into least count. So this will be how much? 0. When it is plus, you don't write any sign. Only you write sign for negative. 0.6. Okay. So now you will say minus 0.06, right? So measured value. With positive zero error correction is equal to 5.36 minus 0.06. And this will be how much? So this will be equal to 5.30. So measured value with positive zero error correction. Now let's calculate the negative zero error. Now this is little tricky. Okay. So here again, the zero is on the left side. So in this case, zero error is found out like this. First you write the minus sign. Then number of vernier division, full division was 10 minus coinciding division.
Into least count.
Yes. Then it is. This is the catch here. Okay. So now, so how much is this? This is minus 10 minus. Again, in this case, also 6 division is coinciding. 0.01 centimeter it will. Why centimeter? Because main scale reading we have taken in centimeter. That's why this was in centimeter, right? That's why. So every least count also has to be taken in centimeter. This is minus 4 into 0. This is equal to minus 0.04 centimeter. This is the negative zero error. Okay. So measured value with negative zero error correction.
Minus.
Yes. Now this is 5.36 minus 0.04. So this will be added. So this will be 5.40. I hope with this example you have thoroughly understood how to take reading when there is no zero error and when there is positive zero error, when there is negative error. Okay. So if you have understood vernier caliper, screw gauge is even simpler. Okay. Same logic for screw gauge. So
Positive and negative zero error.
yeah. So for screw gauge, measured value will be equal to observed value. So it will be main scale reading, circular scale reading here. Okay. First you write down till here. If you have any doubt, ask. Done. So now we'll be taking measurements using screw gauge.
Instead of BSI, we will use
Wow. Using screw gauge. Same logic. Screw gauge. Just the nature of zero error will change. I'll explain how it is. The measured value is equal to observed value minus this will be CSR, circular scale reading. So same here, coinciding division into least count. Okay? Which division of circular scale? Now here, how to find out? See, the zero is like this. The zero with the baseline. Coinciding means which division is coinciding with the baseline. Okay? Because now the scales are not parallel. The scale is perpendicular now. So whichever division coincides with the baseline. Okay? So that is a coinciding division. So let's see if we have time. I don't think we'll have time. We'll do it in the next class. So you take the formula right now. I'll only explain how to take positive zero error and negative zero error in case of screw gauge. Okay. Now see. So this is the main scale. Right. And this is how your circular scale is. Okay, this is how it is. And when you completely, like when you stud and the screw matches, right now this is stud and this is screw, and the thing whose dimension you want to measure is kept in between. When it is totally tightened, when the stud touches a screw, means no object is there. That time, the zero of the main scale will be here, right? And what happens? The circular scale will also reach here. Okay. This is the baseline. This is the zero of. And now there are markings here. Right. So you have to observe where is the zero of this circular scale. So this zero may lie below the baseline. This is the baseline. Meaning you fully tightened it, and this zero is lying below the baseline. That means it is showing more reading, positive zero error. This zero is like when it is not able to fully reach, that means it is showing more length. So this is a case of positive zero error. So whichever division is coinciding, okay. So this is like 1, because 1 and then this is 100 when it takes full round. So this will be like somewhere 95. Okay, like that. This is 5, so on and so on. So it is showing positive zero error. But if this zero was above, right? And you will see that this zero comes, it's hidden inside it. Okay, that means it is showing less length. So it will be negative zero error. So you can see that figure 1.9, figure 1.9, just check. This is for positive zero error, and for negative zero error,
this zero will come above the baseline and
yes, 2.0, right? No, 1.10. 1.10. 10. Okay. So whenever there is negative, it will be like the zero will be above the baseline. And positive, it will be below the baseline. So you can write down below baseline. Which zero below baseline? Circular. Circular zero.
CSR.
No, circular zero.
That's how.
Because zero error is decided with the zero. Circular scale zero below baseline. Then it is positive zero. In this case, circular scale zero above baseline. Right? So positive zero error will be calculated by the same method. Okay? Only for negative, instead of 10, it will be 100. This is figure 1.9. This will be figure 1.10. Instead of this 10, it will become 100. Okay, here total division on Berkeley scale was 10 only, but here it is 100. So likewise, so this calculation we'll see in the next class. Okay, right now I thought I'll just give you the theory. In the next class, read and count. So we'll solve numerical solves. Okay. These are just the formulas. If there was instrument, then I would have shown you, but then I think I have explained quite okay. If you have any questions, we'll take that in next class. All right. So let the bell ring before I go out. Is this your last class or the first class?
First.
So any questions? Just go through what we have done today. And how to revise the book? Go through the blue boxes. Just that's more than enough. If you have listened to the class carefully, go through the blue boxes and diagrams. A quick way of revision. So just go through it. If anything you want me to explain. So what is the principle of a screw?
Two words. Principle of the screw when it is turned, when one thread is turned.
When the circular scale is turned by one turn, then the screw advances by 1 millimeter. That is the principle. Okay. It will advance depending upon which side is the turn, either left or right by 1. Okay, that's the principle. Sure. And what is the principle of vernier calipers? N divisions on vernier scale are equal to n minus 1 divisions on main scale. Okay. All right. So,
Thank you, sir.